little champions. So today is Saturday and it's time to revise what we have studied in this week, right? So today like in this week we have completed 2 chapters from science, that is acids, bases and salts, and light, reflection and refraction. So first I'll be revising these acid, bases, salt chapters. Some questions also will do, and after that your physics sir will be carrying on and he will be discussing or revising the chapter light, reflection and refraction. Okay, so now let us start with our first chapter, that is acids, bases and salts, for today's revision. So in the first, let us understand a very basic difference between acids and bases. So acids produces H plus ions, right? I know all of you would have known that by now. So one second. Yeah. Acid produce H plus ions, base produce OH minus ions. They turn blue litmus to red and they turn red litmus to blue. Example, HCl, HNO3, NaOH and calcium hydroxide. Okay. Next, coming to chemical reactions of acids and bases. So you will find certain types of reactions. Reactions of acids, what are they? With metals, with carbonates and bicarbonates, and with metal oxides. For non-metals, we will see with metals the reactions of bases with metals and reactions of bases with non-metal oxides. Now let us see these reactions quickly. The first one is reactions of acids with metals. So when it is reacting with acid, we get hydrogen gas and salt. Example, you can see Zn plus H2SO4 will give you zinc sulfate plus hydrogen gas. Now what happens? This hydrogen gas burns. If you bring a matchstick here, it burns with a pop sound. Okay, you can see the experimental setup here. Next is reaction of acids with carbonates and bicarbonates. So whether it is metal carbonate or bicarbonate, okay, we get the same product, and that is salt, water and carbon dioxide. Okay, so you can see here I have taken carbonates, we'll get NaCl, water and carbon dioxide, and if I take bicarbonate, we'll get NaCl, CO2 and H2O. The third one is the reaction with metallic oxides. So acid reacts with metallic oxide to give you salt and water. So you can take an example, copper plus HCl will give you copper chloride plus water. Okay. Next, going to reactions of bases. The first one, reaction of bases with metals. Here also we get salt and hydrogen gas. Example, NaOH and zinc. So this is base, this is metal. You will get a salt. This is salt is important, Na2ZnO2. It is called as sodium zincate. Okay, then you have H2 gas produced here. Okay. Next is reaction with non-metallic oxides. So that one will form what? Salt and water. So you can see calcium hydroxide with CO2. CO2 is your non-metallic oxide. Okay, non-metallic oxide. So this one will also give you salt and water. Okay, fine. Next we have common. What is common in acids and bases? So the first thing that is common is both are good electrolytes, means they can conduct electricity. Okay, now they produce ions when they are dipped in the solution. They produce ions, and that is why they can conduct electricity. For conduction of electricity, you either need ions or you need free ions or free electrons, right? So when you dissolve acids or bases in water, they produce ions, because of which they are very good conductors of electricity. Next is what are the acids released by what are the ions released by acids? They release H plus, and bases release OH minus. Next, this is very important. The process of mixing acid or base in water is an exothermic one. Okay, when you dissolve acid or base in water, it is an exothermic process. So that is why always remember, when you dilute, in the case of dilution, always add acid to water, okay, and not water to acid. Okay, next we have strength of acid. So strength of acid is determined by the pH scale. Okay, so you have 0 to 14 the pH. So here pH 7 is neutral, less than 7 is acidic, more than 7 is basic. Okay, here 2 points you have to remember. Less pH, that means more acidic. Okay, for acidic nature, and if you have more pH, that means more basic. Okay, so if two substances are given, okay, their pH values are given and told you to ask their acidic nature, which is more acidic. So the one whose pH is less will be more acidic. Now if you are given two substances, their pH values are given and asked you which is more basic, the one which is having higher pH value will be more basic, okay. So and here you can remember, towards acid you have like red color and towards base it is blue color, okay. In the middle, that is green color, is neutral, okay. Next you have indicators. So indicators are something which help you to identify whether a substance is acid or a base, okay. So you can see if red litmus is there in the bases, it will turn to blue. Blue litmus is there in the acid, it will turn red, right. If there is turmeric, okay, in the basic solution they will become red. If you have phenolphthalein in the basic solution, it will become pink, okay. And in this one there is colorless. And if you have methyl orange in acids, it is red, and it is base, it is blue. Yellow, okay. And there is something called as olfactory indicators, which can indicate whether it is an acid or a base based on smell or based on odor. So what are the examples for that? We have vanilla, onion and clove oil, okay. So the smell of onion and vanilla decreases in base and remains as it is in acid. So that is how you can use the sense of smell to identify whether it is an acid or a base, okay. Next we have here salts. So salts is produced by the reaction of an acid and a base, and this reaction is called as neutralization reaction, right, okay. So now here we have acidic salts. Under acidic salt you have strong acid and weak base. pH is less than 7 and example is NH4Cl. So here you can see the base is NH4OH, which is a weak base, and the salt is HCl, which is a strong acid. Then for basic salt you have strong base and weak acid, pH is more than 7, and here we have CH3 COOH plus NaOH, okay. So here you can see this is a strong base, this is a weak acid, so the salt will be basic and the pH will be more than 7. For neutral salt you need a strong acid and strong base, NaCl, NaOH plus HCl, okay, fine. Next we have the salts that is formed from common salt. So from common salt we can get many other salts, like first one is we can get sodium hydroxide, okay. Then we can get bleaching powder, baking soda can be produced, then washing soda. These all salts can be produced from one salt, that is common salt, okay. And last we will discuss about plaster of Paris. So common salt, all of you know from common salt. So this one is actually your sodium hydroxide, okay. So when NaCl solution, or called as brine solution, undergoes electrolytic decomposition, or if you take a solution of NaCl and you do electrolysis of that, you get chlorine, hydrogen and NaOH, okay. So you can see if you take NaCl and water and pass electricity here, what we will get? NaOH, Cl2 and H2. What are the uses of these byproducts? So NaOH is used in soaps and detergents, hydrogen can be used as a fuel, and chlorine is used as a disinfectant and used in water treatment, okay. Next coming to bleaching powder. So if you have remembered in the previous we got some chlorine ion, right, Cl2 gas was produced. So if you treat calcium hydroxide with chlorine, we get CaOCl2, which is nothing but your bleaching powder, okay. What is the use? It is used for bleaching cotton, used as an oxidizing agent and used for the disinfection of water. Next compound is your baking soda. Baking soda is NaHCO3, sodium bicarbonate, okay. How can you treat this? How can you prepare this? If you take NaCl, water and carbon dioxide and NH3, NaCl, water, CO2 and NH3, you will get NH4Cl and NaHCO3, which is nothing but baking soda, okay. Now this NaHCO3, when you heat, it decomposes to give you Na2CO3, water and carbon dioxide, okay. So here baking soda can be used as an anticid to treat acidity in the stomach, okay. It is used to make baking powder, which is used in the preparation of cakes and bread, etc., okay. Next one is your washing soda, and in washing soda, if you remembered in the previous, so I can say from NaCl, okay, we got NaHCO3, that is your baking soda. From NaHCO3, if you heat it, we got Na2CO3, right? Now if you treat this Na2CO3 with water, you will get Na2CO3 dot 10H2O, which is nothing but washing soda. Okay, so that is Na2CO3 dot 10 water. Clear? Now what are its uses? It is used in glass, soap and paper industries. It is used in sodium compounds such as borax. It is used to remove permanent hardness from the water. Okay. Next compound is your plaster of Paris. The formula for plaster of Paris is calcium sulfate hemihydrate, means CaSO4 dot half H2O. Now it is prepared from gypsum. What's the formula of gypsum? CaSO4 dot 2H2O. Okay. Now if you heat it at 373 Kelvin, this temperature is very important, then you will get there gypsum, sorry, you will get plaster of Paris. It is used in many process. It is used to fix gaps in the wall, making different types of ornaments, for design products, for fractures we use plaster of Paris. Okay. Okay, now we have revised all the reactions. I have gone very fast because this is revision time. Slowly you just need to recall all the concepts. Now we will do some questions. Mild corrosive basic salt is, so corrosive basic salt is your NaHCO3. It is a mild, right? This is strong and this is salt. Not a basic salt, it is a neutral salt. So option number D here. Next one question. Rajesh was given a substance and asked to identify it. He conducted 3 tests on the substances and recorded the results. Okay. It releases carbon dioxide and water and a sodium salt on heating with water. Okay. Then it turns universal indicator greenish blue. Okay. Then you have, it can be prepared from ammonia as a raw material. This is very simple. Okay. So this tells that R must be, it is one second, was given a substance and was asked to identify it. Okay, and so this one, let us read. What substance was Rajesh given? So it was used, ammonia was used to prepare it, then definitely it is nothing but your baking soda, that is NaHCO3. The first one is NaHCO3, right? Next you have, give one use of this substance based on the properties mentioned in P and Q. What is mentioned in P and Q? It releases carbon dioxide and water and the sodium salt on heating. So its use can be as an antacid, okay, or it can be used in the toothpaste. So we are generally talking about its basic nature, right? So basic nature, what is the use? It is used as antacid, or so as a base it is used in these two properties. Next is, Rajesh later read that crystallization of sodium salt formed in P. Okay, crystallization of the sodium salt formed in P. So if I see here, what is actually formed here? If you heat NaHCO3, okay, if you heat it, we get Na2CO3, okay, plus CO2 plus H2O, right? So it really Rajesh later read that crystallization of the salt, okay, formed in P gives another basic salt which is used in the manufacture of borax. Identify the sodium salt formed in P. So this is nothing but Na2CO3. Okay. Next, salts are formed by the neutralization reaction between an acid and a base. Complete the following table by filling the missing data. So you have NH4Cl, right? So the base must be here NH4OH, okay, and the acid is HCl. Next you have copper sulfate, that is CuOH whole 2, that is the parent base, okay, and salt is copper sulfate, okay, that means acid must be H2SO4, okay, that's very simple. Okay, next a compound X on compound X of sodium is used as an antacid and it decomposes on heating. So just now we discussed, used as an antacid is sodium bicarbonate. Name the NaHCO3 and the name is sodium bicarbonate. Okay, write a balanced chemical equation to represent the decomposition of X. So that we have just written again. We need to balance this one. NaHCO3 will give you Na2CO3 plus CO2 plus water, right? So if I want to balance it, definitely I have to make 2Na, 2Na. Now I have 2 carbonate, so here, so I can say 2 carbon, so I have 2 carbon, then I have 6 oxygen, so 6 oxygen, and then 2 hydrogen. Yes, this is also there. Give one use of the compound X beside an antacid. It is used as a pain relief, like I can say pain relief in case of ant bite or insect bite, you can write down. Okay, let us see next question number 5 here. State the chemical properties on which the following uses of baking soda are based. So it is used as an antacid, so that is because of its mild basic nature. Okay, that can be used as an antacid. As a soda acid fire extinguisher, that is because of its ability to produce CO2. To make bread and cake soft and spongy, that is also due to the production of CO2. How is washing soda obtained from baking soda? Write the equation. So if you have baking soda, okay, and if you heat it, you get washing soda, or you said get Na2CO3. Okay, so this is there. Now if this one, okay, is treated with 10 molecules of water, we get Na2CO3 dot 10 water. Okay, that is nothing but washing soda. Okay, and this is baking soda. Okay, so yes students, so with this my revision or your chemistry revision of acids, bases and salts is over, and from here onwards now you will be meeting your physics sir who will be discussing or revising the chapter light, reflection and refraction. Okay.
Hello students, so you have enjoyed Aishwarya Ma'am's revision. So now I am going to revise all the topic of lights. Yes, the complete chapter of light. So we have done some chapter discussion last week and we have completed this chapter already. So today I am going to revise the entire chapter so that you are prepared for your weekly test tomorrow. It will be a full syllabus test. So without any delay, let's start with the chapter revision. So first of all, let's see the entire chapter tree. So now we can see the tree as a whole, because initially when we started we have only looked into one part, we skipped another part, but today we can see the entire part. So first start with reflection. Reflection happens in two ways: spherical mirror. In spherical mirror we see concave and convex mirror, and in plane mirror also we see reflection, right? But spherical mirror was our entire focus. Now similarly we see in refraction we can see glass slab and lenses. In lenses we see concave lenses and convex lenses. There are two types of lenses. Then in spherical mirror we also have seen different terms, okay, image formation, sign convention, mirror equation, etc. Right, we have completed all those things. Again, in case of lenses we have learned image formation, lens equation and power of a lens also. So these everything we have completed. So today we are going to revise everything quickly. So without any delay, let's start with the reflection of light. So when light traveling from one medium to another medium, a portion of the incident light bounces back to the first medium from the boundary separating the media. This is known as reflection of light. So reflection of light is nothing but when light is traveling from one medium, suddenly falls into another medium and it bounces back to the first medium. This process is called reflection of light, right? We have already learned. If you are also like the reflected light and you are still not finding your way home, you are getting reflected everywhere once in a while, then don't worry. If you are still confused about your future, where you will want to head, and every time you are getting reflected like that poor beam of light, then Diksha is presenting DSAT, the Diksha Scholastic Aptitude Test. Every Sunday in our Diksha campuses we are conducting DSAT. It is a very specific test which will determine your competency for different exams that you might take on in your future. So first of all, this is a concept based lecture, 1 hour concept based lecture. Based on that concept based lecture, there will be a orientation. Okay, and after the orientation there will be an aptitude test. Whatever was in the lecture, after the class is over, you can clear your doubts in the orientation session, then you can appear for the aptitude test. Based on that test result, there will be a counselor who will guide you on one-on-one basis what is perfect for you, what is your competency level for KSET, JEE, NEET, that is whether you want to choose engineering, whether you want to choose doctor in future. Okay, what is your future subject should be, that will help you to decide your career. Right now here we have the form. The link is given in the description. You can click on the form and fill the form, and our guys will contact you. Okay, so without any delay, don't be that reflected light only, find your own path. Right, so let's start with the next part, laws of reflection. So this is the law. If theta I is the angle of incidence and theta f is the angle of refraction, then from the laws of reflection we know that theta I equals to theta r. You already know that without any mistake. Okay, so here we can see that light ray is incidenting between here. This is a surface and it is reflecting in this direction. So this is angle of incidence, this is angle of refraction, and basically they are same. And in common term we also represent, instead of writing theta I, we generally write I, and angle of reflection is angle R. Okay, in refraction also we use similar symbols, so don't get confused. If you are using reflection, R represents angle of reflection. If you are using refraction, R represents angle of refraction. Okay, the incident ray, the reflected ray, and the normal drawn on the point of incidence lie on the same plane. We already know that. Right, now next part, spherical mirrors. Let us discuss what is a spherical mirror. Okay, spherical mirrors are part of a one-sided silver. Spherical mirror part of a sphere. Okay, so spherical mirrors are part of sphere with one side silvered. Right, and they have different terms like center of curvature. Center of curvature is the center of the entire sphere. Okay, this is the reflecting surface. We already learned about those. Right, and there is a focus. We will discuss that in a while. Now there are two types of spherical mirrors. One is concave mirror, another one is convex mirror. Okay, so convex mirror are outward bulge, and they looks like this. So if you are looking from this side, this is a convex mirror, and the inner wall is silvered. Right, silvered means they paint with the silver painting, so that from the outside this appears to be a reflecting surface. So when you are looking from this side, it appears to be a reflecting surface. Okay, concave bulge. Concave means inward bulge. Okay, so inward bulge means when you are looking from this side, as I said, if you are standing in front of the mirror and if you are walking towards it, it appears to be a cave. That's why the name concave. Okay, and convex means it is coming outward, vexing towards you. Okay, now so as we have know, there is a focus. There are two types of focus. First is the focus due to a concave mirror. So parallel rays are falling, and after reflection they are meeting at some point. This is a real point. Okay, and this is a focus for concave mirror. And for convex mirror, they usually don't meet. After reflection, parallel rays of light, they appear to come from a point behind the mirror. That point is called the focal length, and there is a relationship between focal length and radius of curvature. Right, we will see that in a while, R and F. So the relationship between radius of curvature and focal length is R equals to 2F. Right, so this is the center of curvature. What is radius of curvature, if you have forgotten? So there it is a part of a sphere. Right, we have seen that. So a spherical mirror is a part of the sphere. So the sphere has a center. Okay, and that center is called center of curvature. The distance between the center and the surface is called radius of curvature. Okay, so if you have forgotten that, I am here to remind you. The radius of this sphere is called center of curvature. Radius of curvature, and the relationship between R and F, here it is F. Okay, if you can see, this is C, this is F. So this relationship between R and F is R is equal to 2F. So focal length, that definition that we have learned, is basically related like this. What next? Convex mirror summary. So convex mirror, we know that convex mirror only forms one type of image. What is it? A virtual image for a real object. Okay, convex mirror, when you keep an object in front of a convex mirror, okay, there is an object, the ray is falling on the lens mirror. Okay, after reflection, how to draw the ray diagram? This is the focus, right? So after reflection, it goes along this direction. Okay, there is a center of curvature, so you can draw it like this also. So if you join them, okay, so this is the line. If you draw it using scale, it will be perfect. So you can see that they are this ray is going in this direction, reflecting along this direction. This ray is going in this direction, it is refracting in this direction. So they are not actually meeting in the real world. This is the real world, this is the world that we live, okay, and this is the mirror world. Okay, if you are a fantasy fan like me, then you know what is mirror world is, right? So this is the mirror world where there is no objects, but you see a virtual object. Yes, upside down, but not upside down. Upside down is case of lenses, right? So here you see that object is smaller than actual it is, and it is a virtual image because rays do not meet. You have to extend them backwards direction to get an image, so that's why it is a virtual image, right? So for any object, be it parallel, if it is object is at infinity, that is all the rays are parallel to each other. Parallel rays means the object is at infinity, right? So in that case, image is formed exactly at focus. Otherwise, object is formed between focus and optical center of the lens. Okay, so this is the main point. Okay, for all other points, this is the image. Now let's move on to the image formation by concave mirror. For concave mirror, I told you I will teach you about the position for u is equal to r, but unfortunately some reason I was not able to come and explain that. But yes, today I am going to discuss it. So we have a sphere concave mirror. Okay, so as I said, whenever you are drawing a concave mirror, use your compass, use your scale, use your pencil to draw it properly, right? So suppose this is your compass position, so this will give you the center of curvature. For this diagram, keep at least 5, 6 or maybe 10 centimeter radius. 10 centimeter, little bit more, 8 centimeter is sufficient. Okay, maximum 8 centimeter you keep as radius. Okay, so you do not draw the entire circle, draw only the part of it, then you do this represents the silver side. Now if this is 8 centimeter, okay, you draw a 2 centimeter arrow upside. This is the trick to draw this. Do not point the F. Okay, in any other case, for any other type of diagram, you put the F in the midpoint. That is, if you have taken 8 centimeter as radius of curvature, then 4 centimeter would be your focus, but not for this diagram. This diagram is a special diagram. Okay, so what you have to do, you have to take an arrow in the upward direction. Say 2 centimeter, you have taken a 2 centimeter arrow upward direction. Then at the same position, you take an arrow of 2 centimeter in the downward direction. Okay, so both objects and image should be of the same height. In this case, it is not. So let me correct that. So this is my object. So this will be my image. Right? So what you have to do, you have to figure it out. 2 centimeter up, 2 centimeter down. Okay, first you draw the image. This is your image. So basically this is a kind of cheating, but you have to do the cheating to get the exact accurate position for this image. So now parallel ray, draw the parallel. Now what you will do, you will do the parallel ray parallel to the principal axis, and then you join this point and this point. Okay, you don't need to know the focus. You simply join these 2 points using a scale. Okay, approximately you will get this. Next will be you join this point and extend, and then you join this point and this point. If in a perfect world, in a perfect world, this line will also be parallel, but because our world is not imperfect, because there are some inaccuracies there, okay, this line may not be exact parallel, slightly up and down, but that is fine. That is okay, that is under the tolerance limit, but you have to have make sure that this and this are matching. So how can this question may come in your exam? Okay, they will not ask you directly about this diagram. They will not say when the object is put at 2f, draw the ray diagram. When the object is placed at center of curvature, draw the ray diagram. No, mostly they will not ask you like that. They will give you some scenario. Okay, they will give you some table, some case study, where there will be one case where you see that the focal length or the object distance, say object distance is 30 centimeter, image distance will also be 30 centimeter. So this is the case where object and image are located at the same position, right? So basically this is the case where you have to draw the ray diagram. Now they will say draw the ray diagram for this case. So that will be your case, and whenever you are drawing a ray diagram from a case study, don't make the mistake like if the object distance is 30 centimeter, you have to draw a diagram where the distance is 30 centimeter. No, this distance can be any distance. This can be 5 centimeter, 10 centimeter, 8 centimeter, as you choose, because scale is in your hand. You can choose any distance to be representing the 30 centimeter. For example, I am giving one example. You have seen the map of India, right, on books, but the map of India shows that the distance between say Bangalore to Delhi is very small. Is it very small? Actually it is a very 3000 kilometer, almost 3000 kilometer distance, or 2500 kilometer distance, right? So 2500 kilometers you cannot show in that map. So map is a miniature representation of whatever the actual distance is. Okay, similarly this is a miniature representation of whatever value they have given you in the exam. So don't worry too much about if you have to show exact 30 centimeter or not. No, you don't have to show exact 30 centimeter, but the image should be exactly matching with the given data. So if they have given you data which shows that object is located at center of curvature, then whenever you are drawing the diagram, your image should also be located at center of curvature. That is the main purpose. Okay, so that is the main thing that you have to realize. You don't need to match the exact scale given in the question, but you have to match the sense of the question. Now let us look into the detailed table for concave mirror. So when the object is at infinity, position of the image is at focus, highly diminished, point sized, real and inverted. Okay, beyond C, between F and C, diminished, real and inverted. I told you these are all discussed. At C, that is center of curvature, this is the most important. Image is also at C, same size, real and inverted. Okay, between C and F, this is also important. Beyond C, enlarged. So if you see only in this case, the size of the image is enlarged. So if they say a concave mirror producing enlarged image, that means you need to know that object is placed between C and F. Okay, so these are the points that you have to remember. Okay, and if the image is same size, definitely then it is exactly at C. If the image is diminished, okay, it can be anywhere between infinity and C. Okay, even at infinity it is highly diminished, point size. If the image is point size, then object is at infinity. Okay, so these are the things that you can relate from regular questions. Okay, at F, okay, it is highly enlarged, image is exactly at infinity, very far away. Okay, you cannot even see this image, and real and inverted. A huge size image, it is so huge that you will not be able to see it. Now between P and F, this is a special case as well. In this case, image is formed behind the mirror. Okay, it is an enlarged and virtual and erect image. So this is the only case where concave mirror is forming virtual image. Okay, so only case where a virtual image is being formed by a concave mirror. So concave mirror can produce virtual image as well, but in this case concave mirror will be producing enlarged image. Unlike in convex mirror, in case of convex mirror we have seen the image is diminished. All the cases image is diminished. Only one mirror can produce enlarged virtual image, that is concave mirror. So one time I have see one question where they mention that the mirror which can produce enlarged virtual image. So they have not mentioned it is a concave mirror, but they have given you a hint that the mirror which can produce enlarged concave mirror, enlarged virtual image. So enlarged virtual image is possible only by concave mirror, not by convex mirror. So you have to be careful about that. Now this is the sign convention. So I explained this diagram as well, that sign convention is along the x-axis is anything is positive, this is x-axis, this is your y-axis, anything along the y-axis is positive, anything along negative x-axis is negative, anything along negative y-axis is negative, and this P is actually your origin. Okay, this P is actually your origin. So if you draw your xy axis like you draw for geometry, like you draw in your mathematics class, same thing is applicable here. So basically instead of a straight y-axis, they have given you a slightly curved y-axis, otherwise it is same. Okay, so basically you can consider this as your y-axis. So y dash, okay, x dash, so and you can add the arrows. So anything in this direction is positive, anything when you are measuring in this direction is negative. And you have to remember that object distance, because we place the object always on our left hand side, that is the standard procedure. So object distance is always negative. Object distance is always negative. Okay. Now next is magnification. For mirror, magnification is given by minus v by u. Magnification is basically how bigger or how smaller the object is. Okay, if the magnification is greater than 1, then it is a magnified image. If the magnification is less than 1, then it is a diminished image. Now you should remember that if m is negative, then it is inverted image. Right, now what is the meaning of inverted image? Inverted image means it's also be a real image. Okay, because only real images are inverted. Okay, we will see the same thing, same logic in case of lenses as well, right? So in any inverted image are basically a real image. Okay, so negative sign of the value of the magnification indicates that image is real. A positive sign in the value of the magnification indicates that the image is virtual. So basically not only real, it also indicates that it is a inverted image. Inverted image means it's a real image. Okay, now let's move on to some example problem. A concave mirror produces 3 times magnified enlarged real image of an object placed at 10 cm in front of it. Where is the image located? A small problem, 2 marks problem. So the magnification is given by 3. Okay, now 3 times magnified real image, they have mentioned real image, so real image means it will be -3 always, right? And object is placed at 10 cm. So object is placed at 10 cm. We know that for a mirror, magnification is given by minus v by u equals to -3. Right, this minus and this minus cancels. We are trying to find v, so v equals to 3u. Okay, and object distance is minus 10 cm. Object distance is always negative, right? So object distance will always be negative. So v equals to 3 minus 10, that is minus 30 centimeters. So what is the meaning of this negative sign? The negative sign represents that the image is on the same side as the object. Okay, so image is on the same side as the object. Okay, so this is a real image. The object distance is 30 centimeter on the same side of the object. Okay, now let's move on to the refraction and its laws. Okay, so basically we have seen this that when you dip a pencil into water, it appears to be broken on the medium separating the two media. Now why this is happening? Because it due to a phenomena called refraction of light. It appears that when traveling obliquely from one medium to another, the direction of propagation of light in the second medium changes. This phenomenon is known as refraction of light. Now let's look into the, there are two laws. First law is obviously the same as the laws of reflection, when incident light, reflected light and the normal drawn on the point of refraction all lies on the same plane. We are most focused in the second law. What is the second law? The ratio of sine of angle of incidence to the sine of angle of refraction is constant for the light of given color and for the given pair of media. Given color and given pair of media. This law is also known as Snell's law of refraction. This is true for angle 0 less than I less than 90 degree. If this is angle is incident and R is the angle of refraction, then sin I by sin R equals to constant, and this is given by N. N is called refractive index. So basically what is the meaning of that? Suppose a light ray traveling from medium A to medium B, okay, and angle of incidence say I, angle of refraction say R, okay, then it says that sin I by sin R is constant for any given pair of media and for a particular color of light. So if you are using red light, okay, between air, say air and water, pure water, okay, and you conducted this experiment here in India, and again you conducted the same experiment in USA, you will find the value of this ratio is same. Okay, no matter where you are doing, no matter what is the angle, okay, you change the angle, angle of R will change such that the ratio of their ratio is constant. Okay, that is the beauty of this law. Okay, so this is the beauty, that even if you are conducting it in different countries, different conditions, okay, as long as the pair of medium and the ray of light, the color of the light that you are using are same, the value will be same. And even if you change the angle I, the angle R will change such a way sin I by sin R is constant. Okay, now so this sin I by sin R is called the refractive index, and the basic definition of refractive index is given by speed of light in medium 1 divided by speed of light in medium 2. So for suppose we have two mediums, okay, and light is traveling from this medium to this medium, okay, so the refractive index is basically given by refractive index of the first medium with respect to second medium, okay, refractive index, so this is medium 1, this is medium 2, speed of light in this medium is V1, refractive index of this medium is V2, speed of light in this medium is V2. So refractive index of the first medium with respect to second medium, refractive index of the first medium with respect to second medium, this is the symbol that we use. So speed of light in medium 1 divided by speed of light in medium 2. So first we will find a refractive index of which medium. So we have air, suppose this is air and this is water, right? So we are trying to find the refractive index of air with respect to water. So if we try to find the refractive index of air with respect to water, first will be speed in air, next will be divided by speed in water. Now if we try to find the opposite sense, that is refractive index of this medium, okay, refractive index of the medium 2 with respect to 1, refractive index of medium 2 with respect to 1, then it will be speed of light in medium 2 divided by speed of light in medium 1, okay, that is V2 by V1. Okay, absolute refractive index, very very important. Absolute refractive index of any medium is defined by it does not have any number, okay, it is normally represented only by N. Okay, so refractive index is represented by speed of light in vacuum divided by speed of light in medium. Now in most practical cases, vacuum can be considered as air. Why? Because air and vacuum are almost same. Okay, air, for air, if the refractive index, absolute refractive index of vacuum is absolute refractive index of vacuum is 1 for any light, refractive index for air is 1.0003. Okay, so they are very very close, so you can ignore this 0.003 and you say speed of light in vacuum and speed of light in air is almost same. The variation is very small, so we ignore that. Okay, so speed of light in vacuum, because air is more common to us, right? We will, to perform any experiment, we will not always run to the space where there is vacuum. okay, where Sunita Williams and their team is performing some experiments. We cannot do that. So we have to adapt to our own reality. So our own reality says that speed of light in air is almost same that of in vacuum. So we will whatever experiments that we are performing in here is almost perfect. Okay, so this is the absolute refractive index, right? Now image formed by concave lenses. So concave lenses, there are two cases as usual, like convex mirror. What are the two cases? First, parallel rays. Parallel rays means object is at infinity. So parallel rays means object is far away. That's why the rays are parallel. In the object is at infinity. So in that case, after incident, okay, the ray diverges, and if you trace them backward, you will get an object and position where you see the image is formed at the focus exactly. Okay, so this is the also this is the definition of focus. Okay, if you parallel rays incident on a lens, okay, after diffraction, if you trace them back, you get the point which is called focus. This is principal focus number 1. There is another principal focus number 2. So in that case, what happens, if the rays tries to go to that point after reflection, they becomes parallel. Okay, so that is a focus number 2. Now, if the object is anywhere other than infinity and focal length, okay, in fact other than infinity and the optical center O, okay, you will always get a virtual image. Okay, image will be diminished, it will be virtual, and to draw the ray diagrams for a lens, you have to remember two things. First of all, the parallel rays, which is parallel to the principal axis, after reflection, after diffraction, they appear to come from focus, or they go to the focus for convex lens. For convex lens, they actually go to the focus. For concave lens, they appear to come from the focus. And the ray which is passing through the optical center, they pass without any deviation. They go straight. So this is the second point you have to remember, right? Now, next part is concave lens. So concave lens summary is same as that of concave mirror. Okay, convex mirror. At infinity, at focus f1, highly diminished, point sized, virtual and erect. For object position between infinity and the optical center O, between f1 and optical center O, diminished, virtual and erect. Okay, so they always produce virtual images only. Okay, and it is always diminished no matter where you keep the object. Now, next is image formation by convex lens. Now convex lens, I have chosen only two special cases. Entire cases I have discussed. These two special cases are very important. Okay, when you place the image object at 2f. Like concave mirror, first you put the object and you put the image. So you already, while drawing the lens lens diagram, I told you take some distance, draw the lens. Okay, this can be arbitrary, the distances can be arbitrary. Only thing that you have to remember, that if you have drawn this lens, okay, if you have considered, okay, focal length is 4 centimeter, so 4 centimeter is in this side, 4 centimeter will be in this side, and this will be 8 centimeter, this will be also 8 centimeter. The distances should be you can choose any distance. For lenses, this is the beauty. For mirrors, you have to use the center for center of curvature, but for lenses there is no such restriction. You can take any distances you want. Okay, so first of all, only thing that you have to remember, that this, if this is f, this should be 2f. Okay, so if this is 5 centimeter, okay, the distance from center to that should be 10 centimeter. If this distance is 5 centimeter, from here to here should be 10 centimeter. Okay, that is, this is 5 centimeter, this will also be 5 centimeter. That thing you have to be careful about. Other than that, any position is fine. And when you start drawing this diagram, first you put the object, and similarly on the other side you draw the image. This is the first point. Next is draw this parallel ray, and then you join this and this. You don't need to worry too much about f. Okay, and then you draw you join this point and this point using your scale. Okay, in case it is slightly right or left, fine. Okay, it will not be super different, but it will be slightly right or left, that should be fine. Okay, they might deduct some marks if it is otherwise, if it's not matching. Okay, so now you have done. So this point you mark at focus, this point you mark at optical center, that should be fine. Okay, and one more case, it is also very common, case number 6, where you get a virtual image. Okay, this is your object. Okay, and when the ray object is placed between focus and optical center, okay, you get a virtual image behind the lens, right, same side as the object, right, and it's a virtual enlarged image. So convex lens is one of the lenses which produces not only virtual image, but it is also enlarged. Only special case, this is the special case where a convex lens can produce virtual and enlarged image. Only one lens can produce virtual and enlarged image, that is convex lens. Okay, so this is the table. You have to remember, at infinity, object is at position is focus f2, highly diminished, point size real and inverted. Okay, beyond 2f1, between f2 and 2f2, diminished, real and inverted. So all these are inverted. Okay, between 2f1 and f1, it is enlarged real image. Okay, enlarged real image is only one. Okay, same size is only one, diminished is 2. These two cases are where you get diminished image. Okay, at f1 this is highly enlarged. Okay, this is actually at infinity, we generally do not consider it. Okay, between O and f1, okay, same side as the object, enlarged and virtual. And as you know the trend, whenever you see a real image, it is always inverted. Whenever you see a real image, it is always inverted. Okay, if you see a virtual image, it is erect. Okay, virtual images are always erect, real images are always inverted. Okay, now lens equation. What is the lens equation? 1 by v minus 1 by u is equal to 1 by f. There was one mirror equation as well. I forgot to mention that. Mirror equation was, since we are discussing lens equation, let me discuss the mirror equation on this side. 1 by v plus 1 by u equals to 1 by f, okay, or 2 by r. Both are fine. Generally this is the common equation. So if you see, there is only one difference, the negative sign is now here. In case of mirror equation, it is positive. Okay, now this is formula is valid for all situations, all spherical lenses, for all positions of the object. Okay, but you must use the new Cartesian sign convention while substituting the numerical values for u, v and f in the formula solving problems. So the substitution is very important. Now let's look into the magnification. In case of lens magnification, it is again v by u, but there is no extra negative sign. Okay, no extra negative sign, and the condition is same. If the sign is positive, then we get virtual image. If the sign is negative, then we get real image. Also there is one more thing, power of a lens. Power of a lens is defined by 1 by f. Okay, here f is in meters and the unit of the power is diopter. Okay, diopter is nothing but meter inverse. But if you want, the simplest formula is 100 by f. Okay, here f is in centimeter. Okay, so if you put the value, you can directly find this power. Okay, power, generally focal length is represented by centimeters. Okay, and there is one more relation, that f equals to 100 by p. Okay, this is also very useful equation, but in this case focal length is in centimeter. That is the basic difference. Okay, we have compensated for centimeter to meter conversion by multiplying by 100. Okay, next, a convex lens of focal length 20 centimeter can produce a magnified virtual as well as real image. Okay, in this case, so magnified virtual as well as real image. Obviously we know that is this a correct statement? If yes, where shall the object be placed in each case for obtaining these images? So obviously this statement is correct. To obtain real image, we can place the object. This is obviously yes. So first answer is yes. Okay, next answer is place the object between infinity and f. Okay, if we place the object between infinity and f anywhere, it will be a real image. To obtain the virtual image, we can place the object at a distance less than f, or between f and o. Okay, so focal length and optical center, if you place the object between f and o, you get a virtual image, and to place the real image, it can be anywhere between f and infinity and f. Okay, now we have reached here at the end of our lecture, and after this lecture is over, since you are still wondering what to do in your future, don't worry. Here at Diksha we are presenting DSAT, that is Diksha Scholastic Aptitude Test, specially tailor-made for you, where we are bringing up a special test for you every Sunday in our Diksha campuses, where there will be a 1 hour class. Okay, and after the class is over, there will be doubt clearing session. Once the doubt clearing session is over, there will be a aptitude test based on the lecture, and then based on your result of the test, there will be one-on-one session. So there will be a career counselor. He will guide you that what should be your future goal and what is your competency for in future. For example, if you want to appear for JEE exam, or if you want to appear for NEET exam and to become a doctor, or you want to prepare for KSET exam and to become an engineer. So what is your best competency? Based on this test result, they will tell you, and for that you have to fill up this form, and our representative will contact you. The link for the form is given in the description below. If you liked our video, don't forget to subscribe to our channel and share it with your friends. We will be back with mock test results tomorrow. Till then, bye.